According to the National Electrical Code, specifically Annex C Table C1, you're allowed to install a specific number of THHN conductors in a conduit without needing to apply a full derating factor. For example, you can install 9 number 12 THHN conductors in a 1/2 inch conduit and 16 number 12 THHN conductors in a 3/4 inch conduit based purely on conduit fill. However, Section 310.15b2 of the NEC addresses the ampacity derating requirements when you have more than 3 current carrying conductors in a raceway or cable. This derating is necessary because multiple current carrying conductors generate heat, which can affect the insulation of the wires and reduce their ampacity. To determine the allowable number of conductors after applying both conduit fill and ampacity derating, you need to follow a few steps. Firstly, determine the ampacity of the conductors you plan to use. For number 12 THHN, the ampacity is typically 20 amps before any derating is applied. For number 10 THHN, the ampacity is typically 30 amps before derating. Secondly, identify the derating factor based on the number of current carrying conductors. According to 310.15b2, if you have 4 to 6 current carrying conductors, you must derate the ampacity to 80% of its original value. If you have 7 to 9 current carrying conductors, you derate to 70%. If you have 10 to 20 current carrying conductors, the derating factor is 50%. For 21 to 30 current carrying conductors, the derating factor is 45%. And for 31 to 40 current carrying conductors, the derating factor is 40%. Thirdly, apply the derating factor to the conductor ampacity. For example, if you have 4 number 12 THHN conductors, each with an initial ampacity of 20 amps, and you need to derate to 80%, the derated ampacity is 20 amps multiplied by 0.8, which equals 16 amps. And if you have 4 number 10 THHN conductors, each with an initial ampacity of 30 amps, and you need to derate to 80%, the derated ampacity is 30 amps multiplied by 0.8, which equals 24 amps. Fourthly, check the conduit fill requirements. Annex C provides tables that show the maximum number of conductors of a given size that can be installed in various conduit sizes. You must ensure that the number of conductors you plan to install does not exceed the maximum allowed by the table. Finally, consider voltage drop, especially in long runs. Voltage drop can affect the performance of electrical equipment. The NEC provides guidelines for calculating and minimizing voltage drop. Now let's apply these rules to the specific question of how many number 12 and number 10 THHN conductors can be installed in 1/2 inch and 3/4 inch EMT conduit, taking into account both conduit fill and ampacity derating. For a 1/2 inch EMT conduit based on Annex C Table C1, you can install 9 number 12 THHN conductors without exceeding the conduit fill limit. However, because you have more than 3 current carrying conductors, you need to apply the ampacity derating factor. If you have 9 number 12 THHN conductors, you need to derate the ampacity to 70% of its original value because 9 falls into the 7 to 9 conductors range. The derated ampacity of each number 12 THHN conductor is 20 amps multiplied by 0.7, which equals 14 amps. You need to ensure that this derated ampacity is sufficient for the load it will serve. Now, let's consider a mix of number 12 and number 10 THHN conductors in the same 1/2 inch conduit. This requires a more complex calculation to ensure you don't exceed both the conduit fill and ampacity limits. A practical approach is to start with the derated ampacity of each conductor size and then determine how many of each you can include without exceeding the total allowable ampacity for the circuit. However, for simplicity and adherence to the NEC, it's often preferable to limit the number of conductors to avoid excessive derating. A safer approach is to aim for a configuration that requires only an 80% derating factor. For example, you could install 6 number 12 THHN conductors in a 1/2 inch EMT conduit. This configuration requires you to derate the conductors to 80% of their original ampacity, resulting in a derated ampacity of 16 amps per conductor. This provides a total ampacity of 96 amps. For number 10 THHN conductors, with an initial ampacity of 30 amps. Derating to 80% gives you 24 amps per conductor. If you install 4 number 10 THHN conductors, this results in a total ampacity of 96 amps. These examples provide a balance between conduit fill and ampacity derating, ensuring a safe and compliant installation. For a 3/4-inch EMT conduit, according to Annex C Table C1, you can install 16 number 12 THHN conductors without exceeding the conduit fill limit. However, with 16 conductors, you need to apply a more significant ampacity derating factor. With 16 conductors, you fall into the 10 to 20 current carrying conductors range, requiring you to derate to 50% of the original ampacity. The derated ampacity of each number 12 THHN conductor is 20 amps multiplied by 0.5, which equals 10 amps. If you were to use number 10 THHN conductors in a 3/4-inch EMT conduit, and you have 10 conductors, you need to derate the ampacity to 50% of its original value. The derated ampacity of each number 10 THHN conductor is 30 amps multiplied by 0.5, which equals 15 amps. You could consider a combination of number 12 and number 10 THHN conductors in the 3/4-inch conduit, but again, the complexity increases. In general, it's best practice to minimize the number of conductors to reduce the derating requirements. For example, you could install 10 number 12 THHN conductors in a 3/4-inch EMT conduit, requiring a derating to 50%. This gives you a derated ampacity of 10 amps per conductor, for a total of 100 amps. Or, you could install 7 number 10 THHN conductors, also requiring a derating to 50%. This provides a derated ampacity of 15 amps per conductor, for a total of 105 amps. Remember to always consult the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. Also, consider consulting with a qualified electrical engineer or inspector to ensure your installation meets all applicable requirements. These calculations and examples are intended to provide a general understanding of how to apply conduit fill and ampacity derating rules. The specific requirements for your installation may vary depending on the load, ambient temperature, and other factors. Always perform a thorough analysis of your specific situation to ensure a safe and compliant electrical installation. In summary, while Annex C Table C1 allows a certain number of conductors based on conduit fill alone, 310.15b2 mandates ampacity derating when you have more than 3 current carrying conductors. The final number of conductors you can install depends on both the conduit fill limits and the ampacity derating requirements. Always calculate both to ensure compliance and safety. It is also important to consider other factors that might influence ampacity, such as ambient temperature. If the ambient temperature is higher than 30 degrees Celsius or 86 degrees Fahrenheit, you may need to apply additional derating factors as specified in the NEC tables. This is because higher temperatures can further reduce the ampacity of the conductors. In addition to derating for the number of conductors and ambient temperature, you should also consider voltage drop, especially in long circuit runs. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, you may need to increase the size of the conductors. It's also important to properly terminate and splice conductors. Loose or corroded connections can cause excessive heat and voltage drop, leading to potential safety hazards. Always use appropriate connectors and follow the manufacturer's instructions for proper installation. When working with electrical systems, always prioritize safety. De-energize circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses, and follow all applicable safety procedures. If you are not comfortable working with electricity, consult a qualified electrician. Furthermore, consider the type of load that the conductors will be serving. Some loads, such as motors, may require larger conductors due to their inrush current. The NEC provides specific guidelines for sizing conductors for motor circuits. Always consult these guidelines to ensure that the conductors are adequately sized for the load. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to be aware of and comply with all applicable codes and regulations. Local codes may have more stringent requirements than the NEC. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date with the latest changes to ensure that your installations meet the current standard. Consider attending continuing education courses or subscribing to industry publications to stay informed. The goal is always to balance safety, compliance, and functionality in any electrical installation.